Okay, let's start with question 1.
Infrared waves are transverse waves. Complete the sentence. In a transverse wave, the direction of oscillation is to the direction of energy transfer by the waves.
Yeah, so they are perpendicular or at right angle. Okay, transverse waves, their oscillation move 90 degree to their energy wave, and the other type of waves are called longitude. They move parallelly. Oscillation and energy path are parallel. So in transverse it is perpendicular. Okay.
Yeah.
Mm. So you have to put perpendicular here. Longitudinal are
This,
parallel, remember.
the student wrote the following hypothesis. The black-colored flask will emit more infrared radiation than the silver-colored flask during 10 minutes of cooling. Describe a method to test this hypothesis.
Yeah. So
Do they
yeah,
use...
let me zoom it. So this is what we have here: a kettle and a thermometer, and we need a stopwatch also, and a heat proof mat. And then what we have to do, first we place both flask on the heat proof mat. Okay.
Facebook? Yeah.
Then we fill both flasks with same volume of hot water from kettle.
Yeah.
Then we use thermometer to record initial temperature of water in each flask.
Yeah.
Then we start stopwatch and leave flask to cool for 10 minutes.
Yeah.
And after 10 minutes we record final temperature of water in each flask.
Uh, yeah.
And then we calculate temperature change for both. And the flask with greater temperature drop has the flask with the greater temperature drop has emitted more infrared radiation.
Okay.
Yeah.
When will the flask emit infraradiation at the greatest rate? During the... Is it the 5th minute or the 9th?
Yeah, during the first minute, right? Because there is the greatest temperature difference between hot water and the surrounding. In starting it is very hot and surrounding is cold, so it will like the heat will go from higher, from hot place to cold place, right? So
Yeah.
during first minute there will be greatest temperature difference.
Another student investigating the absorption of infrared radiation by different surface colors. The student filled 4 hollow metal cubes with cold water. Each cube was the same size but had different surface color. The cubes are then placed the same distance from an infrared heater. After 10 minutes, the student measured the temperature increase of the water inside each cube. What was the dependent variable? The dependent variable was the temperature change.
Yes, temperature change, exactly.
Uh, Give two conclusions that can be made. So, matte black is best black is best heat insulator.
Yes, they are a best absorber of radiation. Then
Absorb radiation. Then shiny white is worse.
yeah, dull surfaces
Radiation
are better.
absorber.
Than shiny surfaces. Like you can see, matte black is 6.5 and shiny black is 4.
Yep. Figure 2 shows some of the cubes. The cube is filled with water. The weight of the water exerts the pressure on the bottom of the cube. Use physics equation sheet to answer questions 1.6 and 1.5. The equation properly links area, force, and pressure. 1 second. Area, force, pressure. So it means area, force, pressure. 1 second. Area, force, pressure. P equals F divided by A.
Yes, exactly. Pressure equals force per unit area.
Figure 4 shows the direction of the horizontal forces acting on the airplane as it moves in a straight line towards the runway. Determine the magnitude of the resultant right.
I think you're reading, you skipped this 1.7
Uh,
above it, the water pressure. This one.
I don't think I have that.
You don't have it? Okay, look at my screen and try it.
Unless the water pressure at the bottom of the cube is 1,500 pascals. Calculate force of the water on the bottom of the cube. So
Cube is
you can
this.
pressure.
Yeah, so
So force equals
hmm,
what's the equation for pressure again?
pressure equals force over area, right?
So force equals pressure times area. So
Hmm.
1,500 pascals
Hmm.
times
Area we will see from that cube.
0.12 times 0.12.
Exactly.
So 0.12 times 0.12 equals 0.0144. So 1,500 times 0.0. 1,500 times 0.12 squared.
Yeah,
That is 21.6.
21.6 Newton. Yes, exactly. Okay, great.
So I think I don't have 2.1 either.
Um, oh, you don't have this 2.1?
No.
Okay, let's read it.
The figure 3 shows the route of an airplane that takes it as it travels from an airport terminal to the runway. Figure 3 has been drawn to scale.
Okay.
Determine the magnitude of the airplane's displacement from the start point to the finish point on figure 3.
So start point is this and this is the finish point. You have to find this displacement, right? Displacement means shortest distance. So let me just take it here. This is the start point and this is the finish point. Displacement is the shortest distance, so we need to find this distance. This, okay?
Yep.
And what is given is 1 centimeter represents 70 meters. Okay. So do we have any other length here? No. So I think you can just measure it with ruler, right? And suppose whatever you are, let's say using ruler, you get 7.1 meters, okay? So you will multiply it with, because 1 centimeter, let's say this is centimeter, and 1 centimeter is 70 meter. So whatever centimeter value you are getting, you have to times it with 70. So if you, because through marking scheme I know that this is going to be 7.1 centimeter, because 1 centimeter equals 70 meters, so times it with 70 meters, and this will give you exact answer, which is 497 meters. Did you get it?
Yep.
Good. Okay, do you have 2.2?
Yeah.
Okay.
Determine the magnitude of the resultant horizontal force on the airplane. So the magnitude is 4,500 newtons air resistance,
Yeah.
and there's 9,500 friction. So
Yes.
there's 14,000 newtons.
Yeah, if you add these two, you are getting 14,000 Newton. Okay. And in this
14,000.
direction, we have 14,000 Newton also, right? This is
Yep.
14,000. This one is also 14,000, as you can see here. So what is the resultant force? Resultant horizontal force. This is horizontal, right?
Yep.
Resultant means net, total.
So 0.
Zero, because they are in opposite direction. If they are in same, then you will add them, 14,000 plus 14,000. Since the direction is opposite, so you will subtract, and 14,000 minus 14,000 is zero force. Okay, zero Newton. Clear?
Yep.
Because opposite side forces will cancel out each other, equal forces.
Describe the motion of the airplane as it moves towards the runway. Uh,
Because the
it
force
moves.
is resultant force, net force is zero, so it will move with a constant speed in a straight line.
Yep.
It will move with a constant speed.
Air resistance and friction are contact forces. Give another example of a contact force. Um,
Com
push.
okay, compression. Yeah, pushing something. You can write compression, extension. Okay, or yeah, because push is not a type of force. It is just the definition of force. So you should write contact force, or you can write tension. You can write normal. You can write up thrust. Any one of them.
The airplane stops for a short time and then accelerates along the runway. Figure 5 shows the distance time sketch graph of the stage of the journey. Draw the velocity time sketch graph for the stage of the journey on figure 6.
Okay, let me take it. So the okay, if you look at this, this is The horizontal line is drawn to 10 seconds. Here we have 10, right? Starting from 10.
Yeah.
Okay. So we have to draw velocity time graph. So that means the velocity will also start with 10, right? And
Yeah.
as you can see, as the time is increasing, the distance is also increasing. So that means velocity is changing, and we can start it with 10 and it will go like this, okay? Like this. Don't put arrow, just right. And here in from 0 to 10 it is constant, so make line like this and then straight line, okay? Basically like this and this, okay? From 10,
Yeah.
because 0 to 10 it's 0, there is no distance covered from 0 to 10.
Yep.
Yeah.
2.6 airplane takes off from the runway, so its height above the ground increases. Shows how the atmospheric pressure varies with the height of the airplane above the ground. Estimate the atmospheric pressure when the height of the airplane above the ground is 10 kilometers. So at 10, oh, you have to do a line of best fit or something, I think.
Yeah. So let me just let me zoom it a bit. So basically, first let's draw the line of best fit. Uh, to estimate the value, we need to draw a smooth curve that passes through near all the plotted crosses mark, okay, whatever marks are given. So because since atmospheric pressure decreases exponentially with height, the line should be a slight curve, okay? So we have
Yeah.
to, it will go like this. If you see, I think I should make it properly. It will go, uh, this is not working, like this, and it will, if you pass it, something like this, okay?
It has to hit the bottom.
Yeah, it will, because x-axis we have to find ground, estimate atmospheric pressure when height is above 10 kilometer. So
So
just go like
I
this.
go. I think there's
Not going to 10
1,
kilometer
2,
and
3, 4, 5, 6, 7, 8, 9, 10, 16.
the pressure,
Yeah.
okay, let's see. Pressure is, if it goes like this, no pressure, because it is as I said, the graph is going to be a bit curved, so I think it's not
Oh,
going
I,
to
I
happen.
thought you have to go down.
Oh no, you have to take like this, value would go like this, okay?
Okay, so then it would be I think then 1 second. 22, 24, 26.
Yeah, uh you can say this is 26, okay? Yeah, if you go like this, yeah, 26, something like that. So this is because estimate, so your 26 is correct.
Okay. Up to the air surrounding the airplane as the height of the airplane above the ground increases. Above the airplane, the temperature of the air increases.
No,
Oh, no, no. However, the air surrounding the airplane as the height of the Mass of air above the airplane increases average density of the air. Volume of air below airplane decreases.
No, it's the first one. Average density of the air above airplane decreases because as we go up, the atmosphere become thinner. There are few air molecule in the given volume. That's why we find it difficult to breathe, right? Density decreases as we go up.
Yeah.
So it's the first one.
Okay. Some cars have a lever that is used to apply the handbrake. Figure 8 shows the handbrake lever in a car. The driver applies the force shown in figure 8. The force produces a moment about the pivot. How could the driver increase the moment about the pivot without increasing the size of the force? Um,
We should apply force further away from the pivot, right?
yeah.
Yeah. So right, apply force further away from the pivot.
After 3 seconds, the momentum of the car is 24,000 kilograms per meter second. Calculate the mass of the car. 20, mass, momentum, velocity. So, mass, momentum, so momentum equals times velocity.
Yes. So mass is
So,
going to be,
mass equals momentum divided by velocity.
yes.
And divided by velocity. So momentum is 24,000 kilogram
Yes.
divided by, and then you do velocity during first 5 seconds. Um, do I have to do the thing it reached, the highest point it reached?
Yeah, exactly. This point. This is the velocity because after this it becomes zero, right? So this
Yeah.
velocity you have to consider. How much is this?
Um, 15.
Yes, so velocity is 15.
So 24,000 divided by 15.
Yeah,
1,600.
exactly. 1600 kilograms. Okay, good.
Determine the distance traveled by the car during the first 5 seconds of the journey. Use figure 9.
Okay,
Distance traveled equals speed times time.
yeah.
Speed times time. So
Let me show you.
you, you need speed. So speed equals.
Yeah, distance is speed times time. So in first 3 seconds you have to find separately and in last 2 seconds you have to find separately because for first 3 seconds the graph is going like this in a straight line. So in first 3 seconds what is the velocity?
15.
15 times time is 3, right?
Yeah.
So the distance is going to be 15 times 3.
So wait, distance equals velocity times time. Isn't it
Velocity is
speed? Isn't it speed times time? That's what it says.
Okay, 1 minute. We have to find. Yeah, this is what I wrote. Distance equals speed times time. Yeah, this is what I mean, speed.
Speed times time.
Yeah.
That's velocity.
Okay, yeah. Yeah, I mean speed.
So speed equals velocity times time.
Yeah, but we have to find distance, right?
Yep, velocity times time. So the velocity equals 15 times by 3, which is 45.
Yeah.
And then it stopped at 15 for 2 more seconds.
Yeah, so for two more you will have to find, because here the distance is, as you can see, velocity is 0, right?
Yeah.
So
Is velocity just constant at 15?
yeah, I mean constant, not 0, I mean constant. So velocity is constant, and so this will become 15. Velocity is 15, but it is not changing, right?
Yeah.
And the time is 2 seconds.
2 seconds.
So this is going to be 15 times 2, which is 30
30.
meters,
Then
right?
you add them together.
Yeah, so total distance is 45 plus 30 meters.
75. So 75. 75 is speed.
Meters, right?
Yeah.
So let's
So 75 equals speed. So then distance equals 75 times and then 5 seconds, right?
you have to find distance. Distance is,
Yeah, 75, which is the speed, times the time equals distance.
no, 75 is not speed. Let me show you
Isn't
again.
speed velocity?
This is the distance. See, we used this formula. Distance is equals to speed times time.
But isn't that velocity?
Okay.
Or is,
Um, no, that's
so,
speed. Velocity is displacement. Speed is distance over time, right? This is the formula we used for distance. We multiplied these two. Okay.
uh, so how is velocity speed?
Velocity and speed are sometimes equal when the shortest distance is, suppose you have to go from this point to this. This is the only way, okay? And this is the shortest distance. In this case, the velocity and speed become same because this is the only shortest distance and the path is same. So in some
Okay.
cases, speed and velocity become same when the shortest distance is only one.
Yeah.
So total distance is 75 meters.
Um, an emergency driver needs to apply brakes suddenly to stop the car quickly. Driver of the car is distracted. Determine whether the distraction will increase the stopping distance. If the driver is distracted, it means it takes them longer
Hmm.
to press the brakes,
Yeah.
but it takes them longer to notice the emergency.
Yes.
So longer to press the brakes,
Yes.
and it takes It will make his stopping distance larger.
Yeah. So stopping distance include thinking distance. Okay.
Yeah,
So there is an additional time before driver applies brake. So thinking distance will increase.
yep.
Hmm. Okay. So I think we can continue in next class from 3.5. Okay.
Okay.
Okay. Bye.